All right, so one of the things we're going to do through the next several slides is walk through what happens during a titration and the major points of a titration and how we calculate the pH at each one of those points in the titration. So often in the lab, a pH meter is used to measure the pH. So I just have a little flash animation here where we could measure pH. So let's say we started with an acid HCl that was 0.1 molar, and I could measure its pH, and I would expect it to be very low, approximately 1, right? Then let's say I added NaOH to it. Well, at the neutralization point, then I would have NaCl at the end point. And so I could find the pH of NaCl, which here I'm going to get a pH of 7. So one of the things I can say is that when I titrate a strong acid like HCl with a strong base like NaOH, I end up with a solution that is neutral or has a pH of 7 at the end point. So in the lab we use a pH meter often and or indicators to measure where our end point is of our titration. We're going to walk through several examples of titration, starting with a strong acid with a strong base, but typically there are 4 zones in which you might be asked to calculate the pH. Before any titrant is added from the burette, after a small amount of titrant has been added, at the equivalence point, and then after the equivalence point. So first we're going to just look at these 4 zones on a titration graph or a titration curve, and then we're going to review the pH calculation, how we would do the calculation for each region. And the strategy for calculating the pH is different depending on which part of the titration curve we are in. Okay, so step 1 is over here initially, before any titrant is added. So there's no milliliters of NaOH being added. So from the start of the titration, all the way to near the equivalence point, so from here to here, the pH goes up slowly. The low initial pH, for this it's right around 1, indicates the substance being titrated is a strong acid. Now, after the initial point, so anywhere in here is after a small amount has been added, okay? Just before and just after the equivalence point, we have this rapid change in pH, okay? And the third place is at the equivalence point. So the equivalence point very specifically is right here in the middle, okay? And for our example, in the graph here, that's where we would see the methyl red color turn to turn at that equivalence point, or the phenolphthalein turn. So at the equivalence point, the moles of acid is equal to the moles of base, and the solution only contains water and the salt from the cation and the cation of the base and the anion of the acid. Of course, this is a strong acid with a strong base, right? HCl and NaOH. So we're left with water and NaCl, which you see here at the equivalence point. And also at the equivalence point, if you read from the graph, the pH is 7. Okay. Then finally, if you continue to add more base, then the pH will continue to increase rapidly at the beginning and then level off. So to summarize one more time, there are 4 regions of any titration graph. Before any titrant is added from the burette, after an amount of titrant less than the equivalence point has been added, at the equivalence point, and after the equivalence point. How you calculate the pH in each zone is different. So for this strong acid, strong base titration, first we're going to consider each pH calculation separately.